Hi everyone, in this session we will learn about inductance, which is denoted by L, which is represented like this symbol. I am taking a source which is applied to a circuit consisting of a load. This load is not purely resistive one. It contains at least one element other than resistance. It may be RL, it may be RLC, it may be RC, it may be simple LC. Okay, I am applying some source. It may be constant or varying one to a circuit which containing load as not pure resistive element, and here I am taking a wire which is twisted into n number of turns. Then the current, whenever a closed loop path is formed, the current starts flowing. This current will be varying one. This will not be a constant one because it contains load as not purely resistive one. Okay, whenever a varying current is passing through a conductor which is having twisted turns, so electric field will be formed. This electric field is similar to the magnetic field formed by a magnet. Magnet contains north and south pole. The magnetic field will be formed from north pole to south pole. Okay. According to Faraday's law, some voltage will be produced in the conductor contains a particular number of turns. This voltage is directly proportional to rate of change of flux. Okay. If you apply the constant of proportionality, it will be n into d phi by dt. So for n turns, it will be voltage produced will be n into d phi by dt. The total amount of flux produced, if flux is phi is the flux produced per turn, total flux produced for n turns will be n phi, which is directly proportional to the changing current value I. Okay, here if I apply the constant of proportionality, the constant of proportionality is L, which is known as inductance. If I substitute phi as Li by N, it will be this n gets cancelled. It will be L is a constant, L into di by dt. So the voltage, whenever a changing current in magnitude is going to pass through inductor, it will develop a voltage across it. This voltage is nothing but L into di by dt. Okay, the main thing about inductor is it opposes the change in current. Okay, so it produces a voltage across it, and it stores the energy in the form of magnetic field. So next we will see power. Power is nothing but voltage into current. Voltage just now L into di by dt into I. This is Li di by dt. So energy is nothing but integration of power over total time duration. So it will be P into dt. So if I substitute P as L into I into di by dt, dt gets cancelled, so it will be L as constant. I am taking out of integration, it will be I di. Integral of I di is I square by 2. If I substitute that one, it is half Li square. This is the energy stored in the inductor. Energy stored in the inductor is half Li square. Next, inductor, if you take physically, it is directly proportional to square of the number of turns and directly proportional to area of the cross section and inversely proportional to length of the magnetic field. If I apply the constant of proportionality, L is nothing but this constant of proportionality is called nu. Nu is the permeability. Permeability is the ability to support the formation of magnetic field. Okay, if I take nu contains two components, nu naught, nu r. Nu naught is permeability of the air. Nu r is the permeability, relative permeability. Suppose if you see here, I have twisted the wire without any core. That means here only air exists. Nu r will be 1. So only nu naught exists here. Suppose if I want more inductance, nu should be more. Okay, nu should be more to get the more inductance. Suppose if I want to increase the nu r can be increased. Nu r can be increased by using a iron core. Iron core will have high relative permeability value. So to get the high inductance, the wire is twisted over iron core to get the high inductance. Next, I will take an example how the voltage is developed across the inductor. I am taking a current. Here I am taking current is changing. Current is changing from 0 to 5. This is x-axis is time in 2 seconds. Suppose it is constant up to 6 seconds. And the current again changes from 5 to 0 in another 2 seconds. What is the voltage? Suppose I am assuming L as 1. Okay. So voltage across inductor in this duration will be 1 into di by dt. Di is di means final value of current minus initial value of current, 5 minus 0, by dt is final value of time minus initial value, 2 minus 0. It will be 2.5. That means up to here the voltage will be 2.5. Next, from 2 to 6 seconds time, the current value is constant. Suppose L into di by dt, voltage across inductor. If I is constant, differentiation of constant will be 0. So up to here the voltage across inductor will be 0. That means when the current is constant, the voltage across inductor will be 0. This inductor is going to act as a short circuit. It will not provide any opposition. Okay. Next thing is I am taking from 6 seconds to 8 seconds. What is the VL? Here current final value is 0, initial value is 5. 0 minus 5 by 8 minus 6. It will be minus 2.5. So when the current changes, the voltage will be produced. Its sign changes, how the direction of current changes. If it increases, the voltage will be positive. If it is decreasing, the voltage will be negative. Similarly, for any other waveform also we can apply this formula and we can get the equation for the voltage across the inductor. Next thing is XL. This is called reactance. This is omega L. Omega is 2 pi FL. Suppose if the source is not constant, it is having some particular frequency. This is the equivalent resistance offered by this inductance. It is nothing but 2 pi FL. It is directly proportional to frequency. When frequency is 0, suppose this is DC and which is not varying at all, whose frequency is 0, then the reactance will be 0. If it is varying and it has certain frequency, the amount of resistance offered by this inductance is XL, which is nothing but 2 pi FL, which is directly proportional to frequency of the source and inductance of the wire used. Next, I will tell an example how the inductance is used. This is an example of a transformer. Here iron core is there because of it has the highest relative permeability value. So one side we have made the wire twisted into N1 turns. Whenever you apply a source, okay, through this one the current is going to change, so it is going to produce a magnetic field, electric field, flux. This flux links with this conductor as well as this conductor. So here whenever the flux produced by this conductor links with this conductor, here some voltage will be produced, which I am indicating by V2. Okay, here some voltage is induced and a closed loop is formed by some load, so definitely some current flows here. Here the application is without any electrical contact, that means isolation is provided from one winding to other winding, but whatever the input energy given, a part of the input energy is transferred to the load with isolation. It may not be there may be some loss, it may not be fully transferred, it will be most of the energy given at the input is transferred to load without any physical contact, and there is isolation. Electrically both are disconnected, these two are connected by electrical flux only. Okay, inductance unit is Henry. In the next session we will learn about capacitance. Thank you.